Hello and welcome. Today we're going to be looking at Unit 10 Electronics. So firstly, the objectives for this chapter: to describe the action of a variable potential divider and a potentiometer, describe the action of thermistors and light dependent resistors and show the understanding of their input as transducers, describe the action of a relay and show understanding of its use in switching circuits. Then also describe the action of a diode and show its understanding as a rectifier, and recognize and show the understanding of circuits operating as light sensitive and temperature operated alarms, to include the use of a relay. Okay, so guys, we looked at the following words previously. You can pause again and just read through it. You might hear these words in the previous video on logic gates. We did discuss this. So firstly, we're going to look at electronic system. And guys, the electronic system also works very similarly to your body, where you have an input. In this case, it's the eye seeing the glass of water, your brain, which is the processor, and your motor neurons, which is your muscles that respond to the decision that's made by your brain. In the same way, computers work in the same way, where we have certain inputs. The processor is the CPU, the memory, and the server, and the outputs can either be on the speaker, the printer, or the monitor, but there is a input, output, and a processor in the middle. So here we're looking at a simple design where our microphone is the input, our amplifier is the processor, and our speaker is the output. Okay, so we've discussed digital and analog also previously. The next part we're going to look at is the component. So the first component we want to look at is a diode. The diode is this little thingy over here at the top, triangle with a line, and a diode blocks current in one direction and only allows current to flow in the other direction. So it is kind of like a bouncer, making sure that you can only flow clockwise and not anti-clockwise in the way it's situated here. So we call this forward biased, and this is where the diode allows the current to flow, and therefore the lamp switches on. But the moment we turn it around, either the cells or the diode, then it blocks the current, so no current can flow, and therefore the lights are off. Okay, so diodes have very useful applications. We use them for LEDs also, that creates a light. But one of the other applications is a rectifier. We use diodes to rectify current. So for example, you plug your cell phone charger into the wall, which is an alternating supply. So you've got an alternating supply, but your cell phone only works with direct current, doesn't work with alternating supply. So inside that, your charger, we have a diode. Okay, and this is just very simplistic, how we turn AC into DC. So we put a diode there, and we see that all the negative, okay, and that all the negatives are flowing in the opposite direction, gets cut off, and we have a current and a voltage, then nothing, then a voltage, then nothing, then a voltage, then nothing. There are other ways to even smooth this out much more without having the off parts of the nothing parts, but this is simply how a diode alone can turn AC into DC. Although this is not ideal for something like a cell phone, we need a few extra components to make it smooth, because we don't want to have something switch on and off the whole time, if we could help it. So now next we're going to look at potential dividers. Okay, so a potential divider is not a component, but it's a way that we set up our circuit where we share our voltage amongst two resistors. Okay, and because the 6 volts is now shared between the 10 and the 10, the voltage over this 10 ohm resistor is now only 3 volts. So if I had something that needs a lower voltage over connected in here, okay, I could do that by putting another resistor using some of that voltage. Now if I put a rheostat, or I can put an LDR or a thermistor over here, we can even control whether how much this voltage is. So think of a variable light switch, think about a stove or something like that. The stove doesn't use all the voltage. We have other resistors as well decreasing the voltage, and therefore the plates can only use a certain amount of volts. Okay, so electronic switching. Here we use a transistor. Now a transistor is a type of switch which we can use. We can think of it as a security guard. Okay, the only way to pass the security guard is to either keep him busy or to feed or to bribe him. Let's say we keep him busy or we bribe him. Okay, so the circuit goes like this, and the current's supposed to go through the transistor all the way down, but the transistor blocks the current. Okay, the moment we see here line B, okay, the moment we are busy feeding him or bribing him from line B, we have the opportunity for the current to flow through. But the moment he's not busy, he blocks the current. Okay, so we want to kind of distract him by feeding him or giving him a bribe or something so that the current can flow through him without realizing it. Okay, so this is also a way that we use this for certain switching. So here, for example, we've got a light dependent resistor. During the day, this has zero resistance, but during the night, the light dependent resistor picks up significantly, and that changes the amount of energy here. So basically, at night, this thing causes the transistor to receive more energy, so he's occupied, and then the current will start flowing through this circuit because the transistor is getting a voltage from here. So this is what we call a potential divider, like we said first, and the energy is shared amongst this 10 kilo ohm and that LDR. So the energy that comes here depends on the size of the resistance of the LDR. Okay, so here we've got the similar setup with a thermistor. The thermistor switches on the transistor. So when it becomes hot, think of a fridge. The fridge becomes too hot. We want to switch on the warning bell. So we put a transistor in there. But in this circuit, the transistor doesn't control the actual circuit. The transistor controls another component which we call the relay. So as the thermistor heats up or feels that it's heating up, it switches on the transistor. Transistor powers the coil of part of the relay, which becomes magnetic, attracting that switch. So this is one switch, a second switch, and the relay switch turns on the switch over here, which turns on the electric bell. Now, practically, why we would use a circuit like this, I'm not too sure. Why we would use two switches instead of just one switch, I'm not exactly sure. But this is also a way to use the transistor. This is also how it looks like when we use a transformer, a relay. They put a diode in there for some or other odd reason, and we have an electric bell also over here. Okay, so I hope you've kind of understood this. Please go read through your textbook. This is not the most important work in your textbook. That's why I've left it to last. But please go work through it, read through it, and make sure that you understand this. Have a nice day.